Today we are going to start with a practical, that is your to perform a practical to perform and observe the following reaction and classify them into combination, decomposition, displacement and double displacement reaction. Now, moving ahead further, we require to understand the few things first of all. That is, first, let's start with the single displacement reaction. What do you understand by the single displacement reaction? A single displacement reaction is a chemical reaction where one reactant is exchanged for one ion of a second reactant. It is also known as single replacement reaction. This single displacement reaction, whenever it is going to take place, it takes place in the form like over here a metal A has been taken. You are having the any, you can say any compound BC. So what happens that this B has your A has displaced the position of the B and it has formed this over here. It means that a one reactant has exchanged the one ion of this particular reactant. Like the practical which is we are going to just perform by an stimulator is what? In the case of iron and copper sulfate solution. The copper sulfate solution is what? It is bluish in color. Now, what happens when you are going to put a iron nail in a copper sulfate solution? So, your iron being more reactive than the copper displaces the copper. So, we get a copper metal over here and we get a ferrous sulfate solution. Your ferrous sulfate solution is greenish in the color. Let's look how it is going to happen. In this case, let's look over here. Now this is the iron nail. You just look, the two iron nails are being placed over here. So over here we take a one iron nail and put in a copper sulfate solution and wait for a few minutes. That 30 minutes or 15 minutes is sufficient. You look, the color of the copper sulfate which was bluish in the starting, it has changed to the greenish in the color over here. Now let's look what change has came to the iron nail. We just take it out, put it on the sheet of the paper. So if you look, the color is being changed from the second iron nail. This shows that iron is being more reactive than the copper as displaces the copper ion from the copper sulfate solution and convert it into a solution of the ferrous sulfate, due to which green color is being came over there. Okay, next, coming to the next, that is your double displacement reaction. Now, when we talk about the double displacement reaction, it means a reaction in which two reactants exchange ions to form two new compounds. This double displacement reaction typically results in the formation of a product which we get in the form of the precipitate. Now, in this case, what happened that we have taken a one compound over here and another over here. So their ions get exchanged. Like over here, the C has taken a, your position of the C is being taken by the D, or vice versa, you can say. And we get this equation. The practical which we are going to perform just now is what? That we are going to take a sodium sulfate, barium chloride. So what is going to happen? This sulfate ion and chloride ion, they are going to exchange their positions. So we will get a barium sulfate and sodium chloride. So both the ions has changed the position. Let's look the practical over here. This is an government site from the Ministry of Electronics and Information Technology. Now look over here. What I do in a test tube, I just put a BaCl2 solution. In this test tube, again what I do, I put the sodium sulfate solution. So if you look what has happened over here, I just zoom it out. A white precipitate has formed. This is what we say that a reaction has taken place. Now in this case, the white precipitate which has been formed over here is what? After decantation also you can look over here. So this precipitate is of the barium chloride. Is it clear to everyone? Coming to the next reaction. The next reaction which we get over here, it is combination reaction. Now what does the combination reaction mean? A combination reaction is also called as a synthesis reaction, as in this reaction two or more elements or compounds are going to combine to form a single compound. Like over here it's shown in the reaction that we have taken the two reactants over here and they have formed a single compound. Like calcium oxide and H2O we have taken, it forms a calcium hydroxide. Let's look a reaction practical how it is going to take place. Now in this, what we have taken a quicklime, pour it in a empty flask, take a distilled water, pour it in a beaker where we put a quicklime, stir it and wait for some time. What happens in this case? A reaction has taken place very vigorously and a large amount of heat is being produced. Now, we have got a lime water. We want to test it. So what we do? We take a sample, put it in a test tube, take a blowing tube and then just we blow a air in it. It turns into a milky. This shows what? That a CO2 contains in the exhaled air turns the lime water milky and the milky appearance is due to the formation and the milky appearance is due to the white precipitate of a calcium carbonate. This finishes our combination reaction. The last reaction for the practical, we have the decomposition reaction. Decomposition reaction. A reaction in which, or you can say a chemical reaction in which one reactant breaks down into the two or more products. This reaction is completely opposite of the combination reaction over here. Let's look, it's practical. Now, thermal decomposition reaction over here. What I have taken as a sample ferrous sulfate. Okay, so let's start a reaction. I just take a ferrous sulfate. We have done in the class also this. Taken in a test tube on the burner. It is very light greenish in the color, or you can say bottle guard color, and we heat it. On heating, what we are going to observe? We are going to observe that slowly that this color is going to disappear, and your salt is going to ferrous sulfate salt is going to change into a white in color. The reason being is what? Because your ferrous sulfate consists of the water of crystallization. On heating, your water of crystallization gets evaporate and its color changes into a white in the color. Look over here. It is becoming whitish in the color and fumes we are observing over here. So what the inference is what? That when you are heating it, what is going to happen? It will change into a white in color because your all water of crystals have been evaporated. But more you are going to heat it, it is going to change into a, when you are going to heat FeSO4, it is going to change into a Fe2O3. Okay. Next, electrolytic decomposition. In the electrolytic decomposition, what we have taken? We have taken a water and we wait for a some time. What happens that your water is going to break down into a oxygen and hydrogen gas and it gets collected in the test tubes. On passing the electricity, it is decomposing in a hydrogen gas which is coming and collecting at the cathode and oxygen gas at the anode. Okay. The last decomposition reaction is your photolytic decomposition. We have taken a silver chloride salt over here and kept it in a light. So observing it, your silver chloride salt is going to convert into a grayish color. That is, it is going to change into a silver metal and your chlorine gas will go on. With this, we finish our practical. Thank you for today, all of you. Just maintain your files accordingly.